What's up? I'm Vin, and today I want to go through the August 2023 Geometry Regents, and I'll leave a link to a copy of this test in the description below. Now let's get started. In this video, we're going to do the part 1 questions, and there's 24 multiple choice questions in this part, and each one is worth 2 credits. Question 1, we have a plane intersects a sphere, and we want to know which two-dimensional shape is formed by this cross-section. So we're starting off with a sphere, and just know that a cross-section is a slice of, in this case, we have a 3D shape. So we're taking a slice of this sphere. So just imagine you have something like an orange and you chop it in half directly at the center. Which shape would you be looking at if you stared exactly at where you made the cut? You would be looking at a circle. Okay, so that's why this is choice 4. Now, there's no way for us to get a rectangle, a triangle, or a square out of this because the sphere is round and we're using a plane to intersect the sphere. So it's coming in here. A plane is kind of like a sheet of paper. It's a flat surface like this. So just imagine when you are slicing this thing, you're slicing it with, just imagine, I don't know, maybe this is a cleaver like this. So that's the plane surface here. And you're chopping it straight through like this. So you're not like making multiple chops. You're doing it in a single chop. So you would be staring at a circle. So definitely choice 4. Question 2, we have the endpoints of line segment AB are A -5, 3 and B 7, -5. And we're told point P is on line segment AB such that the ratio of AP to PB is equal to 3:1. And we have to find the coordinates of point P. So for this question here, what I'm imagining is we have point A over here and we have point B going all the way at the end here. And we're told that point P breaks this segment up into a ratio of 3:1. So the first thing I do is I just add 3 plus 1, and that's equal to 4. And then that tells me to break this line segment up into 4 equal segments like this. And point P is going to be over here because notice I have 1, 2, 3 congruent segments between A and P, and then I have 1 between P and B like this. So that's that 3:1 ratio that I'm visualizing here. And now what I do with this information is I find the change in x. So the change in x here, notice, is going to be the difference of the x values. I would do 7 minus -5, and that's equal to 12. And what that means is if we do -5 plus 12, that's going to bring us to 7. But notice that we're going 1, 2, 3, 4 jumps. So I'm going to take this 12 and I'm going to divide it by 4. And 12 divided by 4 is equal to 3. And I'm just showing it like this because this would allow us to find any one of these points if we had to. So A is at -5, 3. And then this point over here, the coordinate for x is going to be, we're going to add this value 3 that we just found. The distance from this x to this x is 12, but we're going 4 jumps here. So 12 divided by 4 is 3. If I do -5 plus 3, that's -2. And then I would have my missing y value that we'll find in a moment. And now if I just keep adding 3, watch what happens. We get -2 plus 3 is 1, and then we'll find the y value after. And then we do 1 plus 3, we just keep adding 3, we get 4, and then the mystery y value. And then for this, if we did 4 plus 3, notice that it would bring us to x equals 7. Okay, so this is a good start here that we're getting that value 7 that we should be getting. So now for the y value, notice that y is going from 3 to -5. So if we did the value here, -5 minus 3, the change in y is decreasing by 8. However, we are doing this in 4 jumps. So we're decreasing by 8, but we're jumping 4 times to do it. So that's going to be a jump of -2 each time. So if I did 3 minus 2, I'm going to get +1. If I do 1 minus 2, I'm going to get -1. If I do -1 minus 2 again, this time I'm going to get -3, and then -3 minus 2 would give me -5. And notice that it brings me exactly where I need it to like this. So 7 -5, like it's a good thing that we landed at 7 -5. That means we did this right. But we're interested in what are the coordinates of point P, and point P is going to be at 4, -3. Now, one more thing before we move on. If you want a faster way to do this, but this is less conceptual, this is just more of a technique to follow. You look at the A value here, that's where you're starting. And if I want to find my mystery x, I have x equals, and I'm starting at an x of -5. However, if I'm breaking this up into a ratio of 3:1, that means point P is located 3/4 of the way along. So then I would just multiply 3/4 by that change in x, and the change in x we found before was 12. So I multiply this by 12, and I get the x value is going to be equal to 12 divided by 4 is 3. 3 times 3 is 9. So I have -5 plus 9 is equal to 4. And notice the only answer choice that has an x equal to 4 is choice 4. So that's definitely our answer. Now, for a question like this, you should absolutely draw it out. And we have Zach leaning a ladder against a house. So the first thing I would do is draw a house. and the house is on the ground, and we're going to assume that the house is built well and that it forms a 90-degree angle to the ground like this. And now Zach is leaning a ladder against the house. So I'm going to draw the ladder over here, and we're told that the foot of the extension ladder is 8 feet from the base of the house. Now just know the base of the house, this is the bottom of the house, okay? And the foot of the ladder is the bottom of the ladder. So this distance from here to here is going to be 8 feet. Okay, so they're telling us the distance from the foot of the ladder to the base of the house is 8 feet, and the ladder is extended to 25 feet to reach the house. So this distance over here, the hypotenuse, is 25 feet. And what we want to find here, to the nearest degree, what is the measure of the angle the ladder makes with the ground? So just know that the ladder is this piece and the ground is this piece. So the angle that we want is this angle here. We'll just call this angle X. So now let's think of this phrase SOHCAHTOA. And we have to choose the correct trig function based on what we were given. So if the angle X is here, this side that's 8 feet long is adjacent to X. It's next to X. This side over here would be the height of the ladder, like how high up is the ladder going, and that would be opposite of X, okay? So if we had to just label this as the side opposite of X, and then the side opposite of the 90-degree angle is always the hypotenuse. So we know the adjacent side and the hypotenuse, so adjacent hypotenuse should make you think of cosine. So now we're going to do cosine of the angle, cosine of X, is equal to, and it's equal to the ratio of the side adjacent to X over the hypotenuse of this right triangle, which is 25 feet. So for this, we don't have to write the units. The units would just cancel out. We're looking for the angle itself. So now how do we get rid of cosine? What's the opposite of cosine? The opposite of cosine is cosine inverse. So we're just going to say here that X is equal to cosine inverse of 8 over 25. Now, one thing for the geometry regions, make sure that you're in degree mode. If you get a calculator that's been reset, it's going to be reset to radians. So you're going to press mode, you're going to scroll down here to radian, and you're going to go to the right to degree. You're going to press enter, and now we'll be in degree mode. So we press enter, we're in degree mode. Now I can press second mode to go back to the main screen. And now cosine inverse, I'm going to press second cosine. And now I type in the fraction 8 over 25. So we have 8 over 25. And this is going to work out to 71.337. So we're rounding to the nearest degree, which means we're rounding this to the nearest whole number. So we look here to the ones place, we have a 1. And if we look to the right, we have a 3, which is less than 5. So that tells us to round down. We're going to round this down to 71 degrees. So this is going to match up with choice 3. Question 4, Darnell models a cup with the cylinder below, and he measured the diameter of the cup to be 10 centimeters and the height to be 9 centimeters. If Darnell fills the cup with water to a height of 8 centimeters, what is the volume of the water in the cup to the nearest cubic centimeter? So for one, we have to know the volume of a cylinder is pi r squared times h. And we have to be mindful here that Darnell is only filling the cup up to a height of 8 centimeters, okay? He's not filling it to the very top. He's stopping here 1 centimeter below the top. So the height that we're going to use is going to be 8 centimeters because we want the volume of the water in the cup. So we're going to say here volume equals, we have pi times, and we have to be careful here. The diameter is 10 centimeters. The radius is half of the diameter. So if we do 10 centimeters divided by 2, that's 5 centimeters. Now just know here, none of the answers have units attached, and they don't grade you on units in the parts 2, 3, and 4 either. So I'm just going to plug this in here, just the numbers. So we have pi times the radius is going to be 5, and that's being squared. And the height that we're going to use is going to be 8 centimeters. So I'm going to plug in 8 here. So now we evaluate this. We have pi, that's second, and this up arrow here. And then we type in, we have 5 squared. So 5 squared, and we're multiplying that by 8. Okay, so to the nearest whole number here, we're going to have 628, which matches up with choice 1. Now, one thing to be mindful of here, if you're not careful, it's very tempting here to just plug in pi times 5 squared times 9, just finding the volume of the whole thing. And notice that if you round to the nearest whole number, you're going to get 707. But just be very, very careful here, okay? This is a very dangerous bear trap. So you have to read these questions very carefully. We're just finding the volume of the water in the cup. We're not finding the volume of the whole cup. So remember, this answer is no good. This is the bear trap. Our correct answer is the first one here. We're going to have 628 cubic centimeters, choice 1. Question 5, which quadrilateral has diagonals that are always perpendicular? So for a question like this, if you show up to the regions having all of your definitions, formulas, and theorems memorized, then you'll just know that this is going to be a rhombus, okay? Because a rhombus has diagonals that are always perpendicular. But if you forget this, what you could do is draw out each shape. So let's start with the rectangle. So we have this rectangle over here, and right after we draw the rectangle, let's draw in the diagonals. And then we have to ask ourselves, are the diagonals perpendicular? And you can see here that these diagonals are not perpendicular. Notice that these two angles here that I'm marking off are acute angles. So one is out. If we were to draw a rhombus, remember a rhombus is a parallelogram where all four sides are congruent. And then we draw the rhombus and then we draw in the diagonals. You can see in this case here, the diagonals do form 90-degree angles. So that's how we know it's choice 2. Now, the reason why it's not choice 3, we could look at this trapezoid over here. And remember, a trapezoid has exactly one pair of parallel sides. And once we have this trapezoid, let's draw in the diagonals, and we'll make it as neat as possible. So we have this diagonal over here, and we have this one over here, and make that a little bit neater. And then we have to ask ourselves, do these line segments form 90-degree angles? And they don't. So the trapezoid is out. So now for the parallelogram, and I'm going to make this so that it's not a rhombus. I'm going to make these sides here longer than the sides that are going horizontal. So we have these sides down here, and there's the other side over here like this. So there's our parallelogram, and now I'm going to draw in the diagonals. And when we look at this, we got to ask ourselves, do the diagonals intersect to form 90-degree angles? And you can see here that these two angles here are acute. So no, the parallelogram is not always going to give you perpendicular diagonals. The rhombus is our correct answer. Question 6, we want to know which regular polygon would carry onto itself after a rotation of 300 degrees about its center. And these are the 4 shapes we're looking at. Now, just know that a regular polygon is a polygon where all sides are congruent and also all the angles are congruent. And to help us understand this question, I'm going to start off with a square, because a square is easier to draw than all these other shapes. So we have a square over here, and I'm going to inscribe this in a circle. So let's go ahead and draw a circle around the square. And what I'm imagining for questions like this is we have the center of the circle, and then we connect it to the points of the shape. So a square has 4 sides and 4 angles. So we could draw in 4 lines like this that's going to connect all the way out. And I'm connecting them to the corners of the square. So now the idea that you're going to use for all of these shapes is you're going to take 360 degrees and you're going to divide it by the number of sides or the number of angles. And if we look at the square here, we do 360 over 4. That's going to give us 90 degrees. And that tells us that all 4 central angles are 90 degrees. And what that means is if we rotate this square about its center by any multiple of 90, something like 90, 180, 270, or 360, that's going to map this square onto itself. It's going to be facing the same direction, and there's going to be no overlap. So now if we look at a decagon has 10 sides. So we're going to take 360 and we're going to divide it by 10. And that tells us we have to see if the angle 300 is a multiple of 36. So if we do 300 divided by 36, the problem with this is we're going to have a remainder. This is going to work out to 8.3 repeating. So I'll just put this line over like this. And since it doesn't divide evenly, choice 1 is not our answer. Now, a nonagon has 9 sides. So we're going to do 360 divided by 9. And that's going to tell us that our central angle, if we were to inscribe this in a circle, would be 40. And this time around, if we do 300 divided by 40, this time around, we're going to get 7.5. Okay, so you just work this out in a calculator, you'll get 7.5. And we have a remainder here. The 0.5 tells us that this doesn't divide evenly, so choice 2 is out. And now for the octagon, an octagon has 8 sides. So we do 360 divided by 8. And if we work this out, we're going to get 45. And if we do 300 divided by 45, this time we get 6.6 repeating. So you could see here that we have these remainders. So that tells us that choice 3 in this case is not going to be the answer because we need to be able to divide into 300 evenly. So just by process of elimination, the answer has to be 4, but let's see why choice 4 works. So if we do 360 divided by a hexagon has 6 sides, we get 60. So now we see here, if we do 300 divided by 60, this time around, things divide nicely. 300 divided by 60 is 5. And notice that this divides evenly, so 4 is definitely our answer. Question 7, the rectangle drawn below is continuously rotated about side S. Which three-dimensional figure is formed by this rotation? So for this question, we need to be able to imagine what it means to rotate something. So I automatically think of rotisserie chickens when I hear rotation. But for this question here, it's going to be more helpful to think of a revolving door. So this rectangle here rotated about side S reminds me of a revolving door. And you could imagine as the door revolves, it's forming a cylinder. So the shape that's being traced here, the three-dimensional figure that's being traced, is a cylinder. So if we look at this cylinder over here, you could see that we could draw this cross section in. We could draw the cross section here, the rectangle, and the rectangle would look something like this if we were to draw it inside the cylinder. And side S is what we're rotating about. So side S would be located here. So you could imagine as this thing starts to rotate, it's going to form this cylinder here. So we just scan the answer choices here. And choice 3, the cylinder, is the three-dimensional figure that's going to be formed. Question 8, we need to find an equation of a line that satisfies two conditions. The line has to be perpendicular to the line with this equation here, and the line has to pass through the point negative 2, 3. And now to go through this question, we need the following concept. So to find the equation of our perpendicular line, we have to focus on the slope. So this equation y equals mx plus b is going to be very helpful for us, because if we could get this equation in the form y equals mx plus b, that's going to tell us the slope of the line that they gave us. The b value here is the y-intercept, and in some cases this is very important, but for this question we only have to focus on the slope. So we're starting off, we have 4x minus 5y is equal to 6, and we're going to solve for y. So we could start by subtracting 4x on both sides. And now on the left side of this equation, 4x minus 4x cancels, and now we're going to have negative 5y is equal to negative 4x plus 6. So now one more step of algebra here. We're just going to divide everything by negative 5. So we divide each term by negative 5, and that's going to get the negative 5 in front of the y to cancel out. So now we're going to have y equals, and now this term here, we have a negative divided by a negative is positive. So we're going to have positive 4 over 5 times x, and then we have a positive 6 divided by negative 5, and that's going to give us minus 6 over 5. So now what this tells us, it tells us the slope of the line that they gave us is 4/5. So now we're going to find the slope of our perpendicular line, and to find the slope of our perpendicular line, we have to use this idea that the slopes of perpendicular lines are opposite reciprocals of each other. So to find an opposite reciprocal, the first thing you do is change the sign. So we have a positive slope, so our perpendicular slope is going to be negative. And then when you find the reciprocal, you just flip whatever number you have. So we're going to flip this fraction, and it's going to become 5 over 4 like this. So our perpendicular slope is going to be negative 5 over 4. So now that we have the slope that we need, we could use this formula up here to find the equation of our line, but this is the slope-intercept form equation. We could use a better formula for this question. We could use the point-slope form equation of a line, which is y minus y1 equals m times x minus x1. And I'd much rather use this formula because this matches all of the answer choices here. Notice that all of the answer choices are in this form over here like this. So we have the slope that we're going to use. We have the negative 5/4. That's our perpendicular slope. And now the point that we have to pass through is negative 2, 3. So that's our x1, y1. So now we just plug this into the formula. We're going to have y minus y1 is equal to 3 equals the slope is negative 5/4. And then we have in parentheses here, we have x minus, and notice that x1 is negative 2. So I could write x minus negative 2, but the minus is going to change this to a plus. So we're going to have x plus 2 on the inside. So now we just look through the answer choices here, and we can see that this is going to match up with choice 2. Question 9, in circle P below, diameter AC and radius BP are drawn such that the measure of angle APB is 110 degrees. If AC is equal to 12, what is the area of the shaded sector BPC? So for a question like this, the first thing I would do is find the measure of this central angle inside this shaded region over here. And notice that we have a straight line, so we could just do 180 minus 110 because a straight angle is 180 degrees. So if we do the subtraction here, this tells us the measure of the central angle is 70 degrees. So now they want us to find the area of the shaded sector. So we have to know first the area of a full circle is pi r squared. So the first thing we could do is find the full area of the circle, and notice they told us that AC is a diameter. They told us AC is a diameter and the length of AC is 12 units. So this diameter is 12 units long. So we have to be careful here. First, we're going to find the radius, and the radius is equal to half the measure of the diameter. So the radius is 6 units long. So now we could find the area of the full circle. So we could do pi times 6 squared, which is going to give us 36 pi. And I'm leaving this in terms of pi because every answer choice is in terms of pi. But remember, this is the area of the entire circle. We just need a fraction of that. So we're going to take the 36 pi and we're going to multiply it by 70 out of 360 because there is 360 degrees of total spin in a circle. Now, since every answer is in terms of pi, I'm going to multiply these numbers together, but I'm going to leave this pi out. So I'm going to do 36 times, and I'm going to press alpha y equals enter to pull up a blank fraction. And I'm typing in here, we have 70 over 360. So we do this and we press enter and notice that we get 7. So this tells us that this will simplify to 7 pi. The reason why I'm leaving the pi out is because if I do 36 pi and then I multiply by the fraction 70 over 360. So we multiply by 70 over 360. Notice that in this case here, the calculator is not going to put our answer in terms of pi. It's going to give us a decimal. So the calculator work tells us that this product is going to work out to 7 pi. So our answer is going to be choice 2. Now just note, if you did write your solution this way in the calculator, what you could do is type in every answer choice and see which one gives you a decimal that matches this decimal here. And if you wanted to do this by hand, you could do 360 divided by 36 is 10. So these two would cancel out and we would turn this into a 10. And then 70 divided by 10 is 7. And then 7 times pi is 7 pi. So either way, we're going to get choice 2. Question 10, in triangle ABC, side BC is extended through C to D. So the first thing I would do with a question like this is draw this out. And we don't have to draw this to scale, but we have triangle ABC. So we have ABC, and we're told that side BC at the bottom is extended through C to point D. So we'll just put point D over here. And now we're told the measure of angle A is 30 degrees. So I'm just going to label this angle up top 30 degrees. And then next we're told the measure of angle ACD, that's this exterior angle out here, is 110 degrees. And now we want to know what is the longest side of triangle ABC. So the big idea for this question is that the longest side is opposite of the largest angle. So what we need to do is we need to find all the missing angles inside this triangle. So notice here we have a straight line, and so far we have 110 degrees. So we could just do 180 minus 110, and that's going to give us 70. And that tells us the measure of this angle over here is 70 degrees. And just know that when you're inside of a triangle, the sum of the 3 interior angles has to add up to 180 degrees. So far we have 30 plus 70. So we're going to have 30 plus 70, and that's going to give us 100. So now what we could do is just subtract 100 from 180. So if we do 180 minus 100, that tells us the missing angle over here, angle B, is 80 degrees. So now let's focus on this big idea. The longest side is opposite of the largest angle. So the largest angle is angle B. And if we go across from angle B, notice that this points to side AC. So side AC is going to be the longest side of triangle ABC. Question 11, we have right triangle ACT has the measure of angle A equal to 90 degrees. So the first thing I'm doing here is just drawing out a right triangle. And at this right angle over here, I'm labeling this as angle A because the measure of angle A is equal to 90 degrees. The locations of C and T is not important, but remember, the location of A is very important. It has to stay attached to the 90-degree angle. So now next, I'll write down this mnemonic here, SOHCAHTOA, because this will help us set up the trig ratios. And what we have next is we want to know which expression is always equivalent to cosine of angle T. So for this one here, it's very important that you pick a right triangle where all of the sides are different. Because if you were to pick out an isosceles right triangle like this one would make more answer choices true and it would confuse you. But you want the one that's always equivalent. So pick a right triangle where all the sides are different. And you could even go ahead and label them if you know right triangles that do work out. For example, a 3, 4, 5 Pythagorean triple, you could just go ahead and label these sides 3, 4, 5. And if you had to verify here, 3 squared plus 4 squared is definitely equal to 5 squared. So this is a valid right triangle. So now which expression is always equivalent to cosine of angle T? So we could just find cosine of angle T, and cosine is the ratio of the side adjacent to the angle over the hypotenuse. So the side 5 here is just always the hypotenuse, okay? Or the side that's 5 units long, side CT, is the hypotenuse because it's opposite of the 90-degree angle. But if we look here at angle T, adjacent to angle T is 4. So is side AT, which is 4 units long. And now we just set this up here over the hypotenuse, which is 5 units long. So we need a ratio that's equal to 4/5. So you could just go through all the answer choices here and see that cosine of angle C, if we went adjacent to angle C over here, we would get 3 over the hypotenuse is 5. So 3/5 does not match 4/5. So choice 1 is out. If we took sine of angle C, opposite of angle C is 4. So this one here, I'll write this over here, is equal to 4 over the hypotenuse is 5. Because remember, sine is the ratio of the side opposite of the angle over the hypotenuse of the right triangle. So we're going to get sine of angle C is equal to 4 over 5, which matches cosine of T. So this answer choice here is looking good. And now we'll just see why the others are no good. If we took tangent of angle t, tangent is the ratio of the opposite over the adjacent. So we go opposite of angle t is 3 over the side adjacent to angle t is 4. 3/4 does not match 4/5. So that's why this one is out. And now sine of angle t, we're going opposite of t is 3 over the hypotenuse is 5. So this answer choice eliminates, and it's definitely choice 2. Now there is another way to do question 11, and it uses the concept of cofunctions. And we have to know that sine and cosine are cofunctions. So the fact that we're starting off with cosine of angle t, we just have to think here which angle is complementary to angle t, and that would be angle c up here. So the idea is if you know that you're finding cosine of angle t, and you know the angle that's complementary to angle t, which in this case is angle c, you could just go ahead and plug that other angle, the complementary angle, into the other function, in this case sine, and that would tell us that cosine of t is equal to sine of c. Now, before we move on, let's explore this concept of cofunctions a little bit more in the calculator so we have a real strong understanding of it. So if I were to find something like cosine of 20 degrees, I want to look at sine of the complement of 20. And the complement of 20 would be 90 minus 20, which would be 70 degrees. And we can verify that once again because 70 plus 20 is 90. So 70 degrees and 20 degrees are complementary angles. But when I plug complementary angles into sine and cosine, notice that I get matching ratios. So that's the idea behind this question once again, that C and T, these two angles over here, are complementary because we already have 90 degrees. So there's 90 degrees missing between those two angles. So those two angles have to add up to 90. So they are complementary. Because once again, cosine and sine are cofunctions that if I pick out random angles, like let's say once again cosine of 35, and then I think what is the complement of a 35 degree angle, the missing angle would have to be 55 because 55 plus 35 would make 90. And when I plug those two complements into sine and cosine, notice that I get matching ratios. And it doesn't matter if I had started off here with sine of 35 and then I had done cosine of 55. Notice that I'm still going to get the same ratio for both of those functions. So once again, this idea of cofunctions can make this question way faster. Question 12, we have a regular pyramid with the square base and it's made of solid glass. And we're told that it has a base area of 36 square centimeters and a height of 10 centimeters. And then next we have the density of the glass is 2.7 grams per cubic centimeter. And we want to know what is the mass of the pyramid. So for this question, there's two main formulas that we have to know. We have to know that density is equal to mass over volume, and we have to know that the volume of a pyramid with a square base is equal to 1/3, and then we have capital B times H, where capital B is the area of the base. And what we're trying to find here is the mass of the pyramid. So first we'll solve for capital M. So I'm going to call this D over 1 so we could cross multiply, and we're going to get M times 1, which is just M, equals D times V. So we have mass is equal to density times volume. So now we'll find what is the volume of this pyramid with the square base. So we just plug in the stuff they gave us here. We're going to have volume equals, and we have 1/3. Capital B, or the area of the base, is 36 square centimeters. So I'm going to plug this in here. And this time around, I'm actually going to include the units because when we plug this into the formula at the end, the density and the volume, I want us to see the cancellation of units that gives us the answer in grams. So we have 36 square centimeters times the height of the pyramid is 10 centimeters. So we're just going to multiply all of this stuff out here. And now this we could just work out here. 1/3 of 36 is 12. So we just multiply those two and we get 12. And then 12 times 10 is 120. But if you had to just type this in the calculator, you could just do 1/3 times 12 times 10, and you're going to get 120. And now we have square centimeters times centimeters to the first, and that's going to give us centimeters to the third power, or cubic centimeters. So now we could just plug the volume into the formula, and we're going to get the mass of the pyramid is equal to the density is 2.7, and the units for the density is grams per cubic centimeter. So I'm just going to write G over centimeters cubed, and we're multiplying that by the volume of the pyramid, which was 120 cubic centimeters. And notice here that the units cancel out. Cubic centimeters cancels out on top and bottom here, and we're left with just grams. And now we just have to multiply these two. So now let's just work this out. We have 2.7 and we're multiplying this by 120. And this is going to give us our mass in grams here. We have 324 grams. So the mass of the pyramid is 324 grams, and this is going to match up with choice 2. Question 13, we have this equation of a circle here, and we want to know what are the coordinates of the center and the length of the radius of the circle. So for this question, we have to know the equation of a circle. So now that we have this equation here, our goal is to rearrange the equation they gave us in this form here. So the first thing I'll do is get the x terms together and the y terms together. Now there's only one y squared term, so I'm just going to group the x terms together, and we're going to have x squared, and then next we're going to have plus 12x, and then I'm going to leave a space here, and I'm going to say plus y squared is equal to minus 27. So I just switched these two terms here, and I'm leaving a space because the algebra we have to do here is completing the square. So what you want to think about next is you want to focus on the b term, and the b term here, that's the coefficient of x, is 12. And you want to take that term, you want to divide it by 2 and square it, and that's going to work out to 36. And that's the value here that we're going to add to both sides. So I'm going to do plus 36 on both sides, and let's just see what happens after we do this. So this part over here, this trinomial, we just have to think of two numbers that have a sum of 12 and a product of 36. And if we think of the two numbers, you're going to come up with 6 and 6. We have 6 plus 6 is equal to 12, and we have 6 times 6 is equal to 36. So now this will factor nicely to x plus 6 times x plus 6, and then we're going to have the plus y squared right after it. So we don't have to do anything with the y squared term because it's by itself, but if we had another y term attached, we'd have to do the same process here to complete the square for the y part. But this part is already packaged up nicely. So now we have negative 27 plus 36 is 9, and now this we could group as x plus 6 squared, and now this right after it I could just say plus y squared, but if we want we could call this y minus 0 squared. That way it's in the form of the equation we start off with here, and this is equal to 9. So now we just have to be careful here. We're going to identify the center, but one thing to pay attention to is that when you look at the center hk, notice that in the equation we have x minus h squared and y minus k squared. So to go from the equation to the center in this point form over here, we just have to take the opposite of each number here. So notice that I have x plus 6, so my center is going to be at negative 6. So I just have to switch this here from plus to minus when I'm going from the equation back to the point form over here. And now I have y minus 0 squared, so that tells me that my y coordinate at the center is going to be 0. And now for the radius, the r value here, just be careful. The radius is being squared in the equation. So I have to take this 9 here and I have to take the square root of it. And the square root of 9 is equal to 3. So our center is going to be at negative 6, 0, and we have a radius of 3. Question 14, I want to go through two different solutions. And the first solution I'm going to go through is going to take longer, but it's more conceptual and it's better for remembering. So we have triangle ABC, and all of this information they gave us is captured in the diagram, except for this part. We have segment DE is parallel to segment BC. So I'm just going to draw in these arrows here to show that these two segments are parallel. And then next we have AD is equal to 12, and we have DB is equal to 8, and then we have EC is equal to 10. And we want to know what is the length of AC, which is this entire side of triangle ABC over here. So we want this entire side length. So I'm just going to call this piece over here X. And our goal is, once again, to find the length of this entire segment here, which is X plus 10. So for the first method, what I want to do is separate the two triangles. So we have triangle ADE and we have triangle ABC. So I'm just going to separate those two, and I'm going to draw them in such a way that they're in the same position so that it's easier to set up the proportion in a moment. So what these two triangles have in common is, notice we have these parallel lines being cut by a transversal. So the corresponding angles formed are congruent. So that means that this angle over here is congruent to this angle. And notice that both triangles share angle A up top. So these two triangles, we could just say, are similar by angle-angle similarity. And now I'm going to go ahead and label these over here in this part of the diagram. So I'm going to call, we have AD is 12 units long. We have AE is X, so we just labeled it as X. And then AB we could find by doing 12 plus 8, and that's equal to 20. And then for this part, AC, we're going to do X plus 10. So we have X plus 10 over here. So now we could set up a proportion on this part of the paper over here. And we're going to have 12 over X. So there's a few ways I could set this up, but I'm just going to compare the left side to the right side. And in this big triangle, I'm going to set up the same ratio. I'm going to compare the left side to the right side. So I'm going to have 20 over X plus 10. So now we have a valid proportion, and we could solve for X by cross multiplying. So we're going to have 20 times X is 20X. So we have 20X equals, and now we're going to multiply 12 times X is 12X, but we just have to be careful here. We have to remember to distribute. So we have 12 times X is 12X, and then we have 12 times 10 is 120. So now we just solve for X. We could start by subtracting 12X on both sides, And on the right side, 12x minus 12x is gone. And I'll write the result over here. We're going to have 8x on the left side is equal to, we're left with 120 on the right. And now we just solve by dividing by 8. And this is going to give us x is equal to, and this is going to work out here. Let's just see. So we have 8 goes into 12 once with a remainder of 4, and 8 goes into 40 5 times. So x is equal to 15, but we have to be careful. Choice 1 is a very dangerous bear trap. We have to be careful here, and we have to remember what was the question actually asking us to find. We want to know what is the length of AC. So from this step here, to find the length of AC, AC is equal to, we have the sum of AE and EC. So we're going to go across 15, and then we're going to go another 10. So we're going to do 15 plus 10, which is equal to 25. So our correct answer is choice 4. Now, before we move on, let's look at one more way to do this. And for the second method, we're going to use the side splitter theorem. And the way the side splitter theorem works is, because we have these parallel segments here, the segment DE is going to cut sides AB and AC proportionally. Okay, so anytime you introduce a segment that's parallel to one of the sides of the triangle, it cuts the other two sides proportionally. So when they gave us AD is equal to 12 and DB is equal to 8, and then they told us that EC was equal to 10, and we call this X, we could just jump right to the step where we say 12 over 8, so this segment over this segment is equal to, we have X over 10. So this is valid because, once again, we know that these two segments are parallel, and we're setting up a proportion involving the segments of the other two sides of the triangle that were cut. So that's why we could use the side splitter theorem here. And we have 8 times x is 8x is equal to 12 times 10 is 120. And notice that we get the exact same equation here. And when we solve for x, we get x equals 15. We plug it back in, and we also get AC is equal to, and it's 25 units long. Question 15, we have this diagram, and we're told that point E is located inside square ABCD such that triangle ABE is equilateral, and then we have segment CE is drawn, and we want to know what is the measure of angle BEC. So that's this angle over here, and I'll just mark it with an X so we know to solve for X. So now let's transfer the information they gave us over to the diagram. They told us that ABCD is a square, so we can mark these 4 sides here as congruent. And we could also say that we have 4 right angles at the corners because ABCD is a square. So next we have that triangle ABE is equilateral. So this triangle on the inside here is equilateral. So that means all 3 sides of this triangle are going to be congruent. So we can mark them with these notches as well. And since we have an equilateral triangle, all 3 angles on the inside are going to be 60 degrees. Okay, in an equilateral triangle, there are 3 60-degree angles on the inside, because if we just add these angles up, 60 plus 60 plus 60 would equal 180. And now next, if we look, notice that in this triangle over here, triangle BEC, we have 2 sides are congruent. So this triangle is isosceles. And if we use the isosceles triangle theorem, the angles opposite of the congruent sides are also congruent. So we can mark this angle over here with an X, angle BCE. So now let's find the missing angle at the top here, angle EBC. And we could use the fact that we have a square, and in the corner we're going to have 90 degrees. So if we do 90 minus 60, this tells us that the missing angle at the top of this triangle is 30 degrees. So this angle up top is a 30-degree angle. So now we could just add up. We could do x plus 30 is equal to 180, because the sum of the 3 interior angles of a triangle equals 180 degrees. And now we just work this out. We're going to have 2x plus 30 is equal to 180. And now we just do the algebra, minus 30 on both sides. And we're going to get 2x is equal to, we have 150. And now divide both sides by 2. And this tells us that x is equal to 75. And remember, we were looking for the measure of angle BEC, which is just the value of x. So x equals 75 tells us our solution is going to be choice 3, 75 degrees. Question 16, we have this diagram of quadrilateral ADBE, and we're told that DE is the perpendicular bisector of AB, and we want to know which statement is always true. Now, the key to this question is to think about, what does it mean for DE to be the perpendicular bisector of AB? Well, that tells us that DE cuts AB in half, and at this point of intersection here, we're going to have 90-degree angles. So now when we jump into the answer choices here, we could start with choice 1. Let's see, we have ADC, that's this angle over here, is congruent to angle BDC. So how would we show that this statement is always true? Well, we could look at these 2 triangles here and notice right away that they share a pair of congruent sides and a pair of congruent angles, because they both have right angles and all right angles are congruent. But notice that they share this side over here. CD shows up in both triangles. So that means that we have another pair of congruent sides. So we could use the side angle side postulate to say that these two triangles are congruent. And once we know that these two triangles are congruent, we know that the corresponding parts of those congruent triangles are also congruent. So we can say that angle ADC is congruent to angle BDC by using corresponding parts of congruent triangles are congruent. So choice 1 is definitely our answer, but let's see why the other answer choices are no good. So choice 2 is no good, and let's clear out some of this stuff here, the stuff that we drew in over here, and let's see why choice 2 is no good. So angle EAC, so that's this angle over here, is congruent to angle DAC. Well, notice that they told us that ADBE is a quadrilateral. They didn't say that it's a parallelogram or a rhombus or a square. They just said quadrilateral. So that means if we wanted to, we could move this point E, we could move it up. And if we move it up, that would make this angle over here change. That angle CAE or angle EAC would change if I drew it like this. So if I moved point E over here like this, notice that this angle changes, which would make these two angles no longer congruent. So it could be true that these two angles are the same if this had some nice symmetry to it, but it doesn't have to be true. So that's why we could get rid of choice 2. So now we move on to choice 3 here, and let's see. AD is congruent to BE. Well, opposite sides of a quadrilateral are congruent when you have a parallelogram. But once again, this is not necessarily a parallelogram. Once again, we could move this up, and if we move this up, this is going to change the length of BE, and then these two sides here would no longer be congruent. So that's why choice 3 is out. And now let's explore. We have AE is congruent to AD. So if I give these the same markings here, well, this is not necessarily true because once again, if I move point E up, so moving point E up just seems to eliminate all the other answer choices. But if these two segments were congruent right now, if I move E up like this, then these segments are no longer congruent because this is just getting closer and closer to this point of intersection, and that's going to change the scenario here. So that's how I know choice 4 is out. Choice 1 is definitely our answer. Question 17, we want to know what is the image of 4, 3 after a reflection over the line y equals 1. And for this question, I'm going to use the scrap graph paper. Now, if you're a great artist, you could just do this freehand, but if you're not the best artist in the world, then I recommend that you use the scrap graph paper in the back of the test. And we have the line y equals 1. That's our reflection line. So I'll make this a dotted line. And that's going to be a horizontal line that hits the y-axis at y equals 1. So this is our reflection line. And we're going to reflect this point 4, 3. So we go to the right 1, 2, 3, 4, and up 1, 2, 3. So that's the point we're going to be reflecting here. And when you reflect over a line this way, when you're using just this technique, you're going to count the spaces to the line first. So we're going to go down 1, 2 to get to the reflection line. So we have to go across the line the same amount. So I went down 1, 2. So I have to go down another 2. I'm going to go 1, 2 like this. And notice that the reflection line cuts these 2 points directly at the halfway point like this. So this is looking good. And now I just have to identify the coordinates of this new point. So we're going to go to the right 1, 2, 3, 4 and down 1. So our image is going to be at 4, -1. So choice 3 is our answer. Question 18, we have this diagram of a cone, and we're told that the diameter of the cone is 16 inches and the slant height is 17 inches. And we want to know what is the volume of the cone in cubic inches. So the first thing we need to know is what is the volume of a cone? And the volume of a cone formula is V equals, we have 1/3 pi r squared times h. And for this question here, we have to know that to find the radius, we're going to take the diameter and divide it by 2. So the radius is equal to half of the diameter. So we're going to do 16 divided by 2 is 8. So the radius is 8 inches. Now we have to be careful here. H is the height, but please don't say h is equal to 17 inches. Okay, this is a very, very, very dangerous bear trap. The slant height is 17 inches, but the actual height here we could call h. And to find h, we just have to know that this part up here represents the radius of the cone. So the radius is equal to 8 inches. So to find the missing value for h, if you know your Pythagorean triples, you would recognize this as an 8, 15, 17. But that's not the most common knowledge. So what you could also do is use the Pythagorean theorem to solve for h. And if we want to use the Pythagorean theorem, we could just say that 8 squared plus h squared is equal to 17 squared because we have the 2 legs here, and this is the hypotenuse of this right triangle here. So now we just work this out. We're going to have 64 plus h squared is equal to 17 times 17 is 289. And now just subtract 64 on both sides. And this is going to give us on the left side, this is going to cancel out, and we're going to have h squared equals. And on the right side, we're going to have 225 after we subtract. And now we take the square root of both sides, and that tells us h is equal to 15 after we do the square root of 225. But if you know your Pythagorean triples, this is just way faster. So now we plug this into the equation. So we're going to have v equals, and we have 1/3 pi, and we're multiplying by r squared. But now I'm not going to write the units anymore because the answer choices don't have units. So we're going to have the radius squared, and we're multiplying this by the height, which is 15. So now we can just type this in. So when we type this in, we're just going to type this in without the pi because the answer is in terms of pi. So we're just going to write that at the end. So we have 1/3, and we're multiplying that by 8 squared, and then we're multiplying that by 15. So we just multiply these three terms together, and this works out to 320. So the volume is going to work out to, and we have to remember, the product of all of the numbers except pi was 320. And now we just tack on the pi, and we're going to have 320 pi, which is going to match choice 1. Question 19, we have this diagram below, and we want to know which congruent statement would be sufficient to prove that the quadrilateral is a parallelogram. So for this question, there's a few theorems that are pretty helpful here. Anytime we have two lines that are being cut by a transversal, and we know that the corresponding angles formed are congruent, that tells us that the lines involved are parallel. And another situation that could pop up is we have two lines like this, and the transversal is drawn in, and we have alternate interior angles are congruent. That would tell us that the two lines involved being cut by the transversal are parallel. So that's the idea we're going to go with here. So if we look, notice in choice 1, we have angle 1 is congruent to angle 6. But this is not the result of parallel lines. Notice that angle 1 and angle 6 are vertical angles. So that's not going to tell us that any pairs of lines are parallel. So this is not a good start for choice 1. And then next we have angle 9 is congruent to angle 14. But once again, these are two vertical angles. So that's not going to make any additional information for us that's useful. We're not going to be able to say anything about pairs of lines being parallel. So that's not going to be sufficient to prove that our quadrilateral is a parallelogram. So we could get rid of this here and say that choice 1 is no good. So now for choice 2, we have angle 5 is congruent to angle 10. And notice that we have alternate interior angles here. So since our alternate interior angles are congruent, the lines involved in forming these alternate interior angles are parallel. So we could say that L is parallel to M based on this statement here. But then we have angle 6 is congruent to angle 9. So if we look over here, these two angles are congruent, and once again we have alternate interior angles are congruent. But notice that the lines involved in forming these alternate interior angles are still lines L and M. So all we have so far is that we have the same pair of lines are parallel. So this is just establishing twice that L and M are parallel. In order to establish that this is a parallelogram, we need to also establish that N and P are parallel. So that's why choice 2 is no good. So now let's look at the third answer choice here. And for the third answer choice, we have angle 5 is congruent to angle 7. So right now we have a pair of corresponding angles are congruent. So when corresponding angles are congruent, the lines involved are parallel. So this is going to tell us here that N and P are parallel. So far we have N is parallel to P. And then next we have angle 10. So angle 10 is over here. And we have angle 15 are congruent. And notice that in this case, we have a pair of alternate interior angles. So the alternate interior angles formed here are parallel, but notice that these alternate interior angles use lines N and line P. So that's just saying the same thing once again, that we have line N is parallel to line P. But in order for this quadrilateral to be a parallelogram, both pairs of opposite sides have to be parallel. So this is not going to be enough. So choice 3 is out. So now just by process of elimination, we could see our answer to this is going to be choice 4. But let's see why 4 is definitely true. So if we look over here, and we'll just clear out this space, the first thing we're told is that angle 6 is congruent to angle 9. Well, if angle 6 is congruent to angle 9, notice that these are alternate interior angles. So the lines involved in forming them are going to be parallel to each other. That's these lines over here. So we could say line L is parallel to line M. And that's the result of that first statement. So now we look at the second statement here, and we have angle 9 is congruent to angle 11. But notice that these two angles over here, so now we shift our focus to these two, are involved when we look at these two lines. So we have lines N and P are being cut by the transversal M like this. So when we have these parallel lines being cut by this transversal, the corresponding angles formed are congruent. So that tells us that these two lines over here are also parallel. So we could say that N is going to be parallel to P. So now if we look at our quadrilateral, notice that both pairs of opposite sides are parallel to each other. So when you have a quadrilateral with both pairs of opposite sides are parallel, that information is sufficient to prove that your quadrilateral is a parallelogram. So 4 is definitely correct. For question 20, we could use the wee-wee rule. So we could use the wee-wee rule anytime we have intersecting secants and we want to find the length of one of the segments. So we have all this information here is transferred to the diagram, and we want to know which equation could be used to find the value of x. So the way the wee-wee rule works is we look at each secant as either the whole segment here like this, or the exterior, which is the piece of the secant that is outside the circle. So for this first secant over here, we'll just say RT is our first secant. We have the entire segment is x plus 5 because we have to go over x and then over 5. So we have x plus 5. That's the whole segment. And then we multiply it by the exterior part of the secant. And the exterior is just this piece over here, x. So we have x plus 5 times x. And now we could say this is equal to the whole segment over here. We just have to add 9 plus 3 is 12. And then we're going to multiply that by the exterior part of the secant is 3. So we're doing 12 times 3. And now we just work this out, and I'll just flip these here because that's how it looks in the answer key. So we have x times x plus 5 is equal to 12 times 3 is 36. And now this matches up with choice 1. Question 21, we have on the set of axes below the coordinates of 3 vertices of trapezoid ABCD, and we have these coordinates here. And we want to know which point could be vertex C. So for this question, we could just plot all of these points. Now, it may be obvious that if you connect this point to point D, and then you connect this point also to point B, that this in fact would form a trapezoid. And we could answer the question that way and see right away that it's going to be choice 4. Otherwise, there's a second approach to this question, but we have to know that in a trapezoid, we have exactly one pair of parallel sides. But if we want to use this information, we also have to know that parallel lines have equal slopes. So if we target this segment over here and we find the slope of segment AD, notice that the slope of this segment we could just find by doing the rise over the run. And if we do the rise over the run, we're going to go down 2. So we're going down 2, and then we're going over 1, 2, 3, 4. So the slope of this line segment here is going to be -1/2. So if we use that slope starting at point B, we could march to the answer choice here. So we're going to go up 1 and we're going to go to the left 2. So we just keep doing this. We go up 1 to the left 2. And notice that it misses this point here. It also misses this point up here. And if we keep doing this, we go up 1 to the left 2. We miss the third answer choice and we do it once more. And then we land onto the fourth answer choice here at the point -3,8. So -3,8 is definitely our solution. Question 22, we have in the diagram below, triangle ABC is congruent to triangle DEC. And we want to know which transformation will map triangle ABC onto triangle DEC. So looking at choice 1, I could see that a rotation is not going to work because if we rotate triangle ABC, and let's say we rotate it about point C, when we rotate it this way, notice that angle B, the right angle over here, is going to map in this direction here like this. It's not going to be facing the direction that we need it to, so that it lines exactly on top of triangle DEC. So that's how I know choice 1 is out. Now, choice 2, a line reflection is looking good because if we drew in a dotted line through point C, we could see that this line here acts as the mirror line to map this triangle on top of this one. And if we wanted to be 100% sure, we could just connect these corresponding points together like this, and notice that our line of reflection is the perpendicular bisector of all of the points and their image. So that's telling us that choice 2 is good. But now let's see, why are the other answer choices no good? So we'll just cross out this stuff over here and explore them. So choice 3 is no good because if we take triangle ABC and we translate it, you could see that if all we do is slide this thing, there's no way it's going to land exactly on top of triangle DEC. Even if we dilate this thing, if we make it bigger or smaller, that's not going to change the direction that it's facing. So that's not going to be enough for us to map this triangle on top of this triangle. And finally, choice 4 is no good because if we do a line reflection followed by a second line reflection, the orientation of the angles is not going to match, and we won't be able to map triangle ABC onto triangle DEC. And what I mean by that is if we look right now at these two triangles, look at the corresponding angles like angle A and angle D. These angles are congruent because we're told that these two triangles are congruent. So I'm going to label them both with a 1. And then this angle over here, I'm going to call 2, and I'll call this angle 2 because this corresponds to angle 2 in this triangle. And then we have this will be angle 3 in both triangles. So notice if I go in a clockwise direction like this, that when I go this way in triangle ABC, the orientation of the angles when I go this way, I get 1, 2, 3. But when I do that in triangle DEC, notice the orientation right now when I go this way is going to be 1, 3, 2. So notice that the angles won't map onto each other. So as they are right now. So I need to do a line reflection to change the orientation of the angles. So when we do the line reflection, these triangles fall exactly on top of each other. So if I do a second line reflection, that's going to mess with the orientation of the angles again, and there won't be any way for them to match once more. So that's how I know once I do a second line reflection that there won't be any way to map this triangle ABC onto triangle DEC. Question 23, we have triangle TAP is dilated by a scale factor of 0.5. And we want to know which statement about the image triangle T prime A prime P prime is true. So for this question, what I'm imagining is we have this point over here, and that's going to be our center of dilation. And I'm going to draw a triangle TAP over here like this. So there's triangle TAP, and I'll just label the points over here like this. And when we're dilating this by a scale factor of 1/2, what that's going to do is I'm just imagining a dotted line going from the center to all 3 points of the triangle here. And when we dilate by a scale factor of 1/2, what we're going to do is we're going to place the image or the points for the image at the halfway point of each of these lines that I drew in. So for the first one here, the image here, T prime, is going to be the halfway point between the center and the point T over here like this. So I'm going to call this one T prime. And then A prime is going to be half the distance from the center here to point A. So A prime is going to go about here. So that's going to be A prime. And then P prime is the halfway point between this point here. We'll just call this the center and this point P over here. So we're just going to say that's going to be at about this location here. So that's going to be P prime. And now if we connect these points like this, we'll just draw that much neater. So we're connecting the 3 points of the triangle. Notice that our resulting triangle here is similar to the original triangle, but the side lengths are shorter. So what we could say right away is that, let's say something like TA, if we multiply TA by 1/2, that would give us the length of T prime A prime. So now let's go through the answer choices. We have first up, the measure of angle T prime A prime P prime. So that's this angle over here is half the measure of angle TAP. Well, just know that when you dilate a triangle, the resulting angles are going to be exactly the same. The shape doesn't change. The only thing that changes is the size. Okay, so if we use this idea that the shape stays the same, what we know is that these two angles are going to be congruent. So we could eliminate choice 1 like this because, once again, these angles should be exactly the same. We're not going to take half the measure of the angles to get the new angles. And now if we look at the next answer choice here, we have the measure of angle T prime A prime P prime. So we're still on the same two angles here, is equal to double the original angle, but that's also not true. Remember, what we could say is that these angles are exactly equal to each other. So that would be a correct answer if we eliminate these coefficients here in front of the measure of angle TAP. But since they do have these coefficients of 1/2 and 2, these two answer choices are eliminated. So now we look at choice 3 and we have TA, so that's this segment over here. So I'll just highlight this segment. That's TA is twice the length of segment T prime A prime. Now this one is true because, once again, we have a scale factor of 1/2. So the length of all 3 sides of the original triangle are going to be cut in half. So if we double the length of the new triangle, the smaller one, that's going to bring us back to the original length. So this answer choice is looking good. And now choice 4 is no good because if we look at segment TA over here, if we multiply the shorter segment by 1/2, that's just going to make this even smaller than the original segment over here. So that's why this answer choice is no good. So choice 3 is definitely correct. Question 24, we have this diagram below, and all of the information they gave us is captured in the diagram except for this part. So this part will just transfer to the diagram. We have the measure of angle AYX is equal to the measure of angle B. So I'm just going to mark these two angles here as congruent. And we want to know which statement is not always true. So the first thing I would do here is just separate the two triangles. I'm going to draw a triangle AXY first, and I'm just going to draw it a little bit different. I'm going to put A here, I'm going to put Y here, and I'm going to put X over here. So I'm flipping this triangle, and the reason why I'm flipping it is so that the pair of congruent angles are going to be in the same position. So Y is going to be over here, this angle is over here, and when we draw a triangle ABC, notice that I'm going to have A, B, and C, and we said that angle Y is congruent to angle B. So now these two triangles are facing the same direction, and it's going to make it easier to set up the proportion. And remember, the two triangles share angle A, so right now we have angle-angle similarity. So now let's go through the answer choices. And these two triangles, I'm going to call this one the small triangle, and I'll call this triangle over here the big triangle. So when we look at choice 1, we have AX over AC. So AX over AC is giving us the right side of the small triangle over the right side of the big triangle. And is this always equal to, we have XY is the bottom of the small triangle, and that should be over the bottom of the big triangle, which is CB. And notice that's exactly what they gave us here. So this statement here is always true. This proportion was set up correctly using these two similar triangles. So choice 1 is out. Remember, we want the one that is not always true. So next we have AY over AB. And if we look at the diagram over here, AY over AB is the left side of the small triangle over the left side of the big triangle. And this is equal to, we have AX is the right side of the small triangle, and we should be over the right side of the big triangle, which is AC. And notice this matches exactly what they gave us for choice 2. And now for these last two answer choices, there's just an extra layer that we have to deal with. For these answer choices, we have to first set up the proportion, and then we have to cross multiply to get these resulting equations. So for choice 3, what I would do is I would look over at the triangles here, and I would highlight, we have AY and we have CB. So we have a left side and we have a bottom side so far. And then on the right side, we have XY and we have AB. So notice that in both triangles, we have the left side and bottom side highlighted. So that's a good start here. And now I'll just set up the proportion myself. So I'm going to say AY over, and I'm going to say XY. So I'm going to do the left side to the bottom side. So I have AY over XY should be equal to the left side to the bottom side. We're going to have AB over CB. And notice if we cross multiply, we're going to get AY times CB first if we multiply this way, and then we'll get this is equal to XY times AB. So this equation here is definitely always true. So we could eliminate choice 3, and choice 4 is definitely our answer. Now, just to be 100% sure here, I'm just going to make sure that choice 4 is not always true. So this answer choice involves AY, so I'll just highlight AY and AB. So far we have the left side and the left side. And then we have, after the equal sign, we have AC, which is over here. So we have AC and we have AX. So now I'm just going to set up the proportion here. We're going to have AY over, so I'm going to set up AY over AX. And this is going to be equal to, so I did the left side to the right side in the small triangle. So this has to be equal to the ratio of the left side AB over the right side, which is AC in this triangle. And now if we cross multiply, look what happens here. We don't get AY times AB. We get AY times AC. And this answer choice right away, I can see now, is not always true, because for it to be true, we would have to get AY times AC is equal to, and then we'd have to get AX times AB. Okay, so if this were the answer choice here, then this would be always true, and this would not be the answer. But because they wrote it out of order, choice 4 is our answer choice.